welcome. This is Algebra 2, Unit 9-1. Why is a sequence a function? So we have a sequence here, 1, 3, 5, 7, 9. The element or position number is the in value. So the first term, because these are called terms, the first term is 1, second term is 3, third term is 5, fourth term is 7, fifth term is 9. Okay? So if you look at this as pairs, do you see how come it becomes a function? Because your x is never going to cheat. Okay? Now, you might be asked, what's f4? All I'm asking is, what's the fourth term of the function? That would be 7. Okay? What happens if I say, okay, a function begins with the 0th term? And here's the function. 0, 2, 4, 6, 8. And then I ask you, what is the third term? Now be careful in this situation, because I've told you that it begins with the 0th term. So instead of this being the first term of the function, I've defined it as that being the 0th. So you'd have to go 0, 1, 2, 3, it would be 6. So really, really watch for some little tricky stuff that way that I might throw at you. Okay? Use the rule, Fn equals n squared plus 1 to generate the first 4 terms of a sequence. All you do is just plug in your position values. Your first 4 terms would be 1, 2, 3, 4. Plug them in for n. 1 squared is 1 plus 1 is 2. 2 squared is 4 plus 1 is 5. 3 squared is 9 plus 1 is 10. 4 squared is, 4 squared is 16 plus 1 is 17. So I might ask, well, what's f of 20? All you do is plug it in. 20 squared is 400 plus 1 is 401. Just plug it into the formula. That is an explicit formula. It's so nice to use because no matter what term you're plugging in, you can just plug it into the formula to find what it is. Write the first 4 terms of the sequence with this function. Now this one is not an explicit formula, it is a recursive. Watch how it recurs, how you have to depend on the one before it. First it says f of 1 is 3, so we know the 1 is 3. Now look what happens with this formula. It says after the first position from the second term on, what you have to do is you have to take your previous term, Fn minus 1, and you have to add 2 to it. So on the second term, you have to take your Fn minus 1, which means second minus 1 is first. So you have to take your first term and add 2. So you get 5. It's not hard to do, it's just your formula doesn't allow you to actually plug it in this term in. Instead, you're having to go to your previous term, because this tells me if I plug 3 in for n, it says f of 2 plus 2. So I have to go back to my value on 2, add 2. Go back to my value on 3 and add 2. So that's not a bad formula when you're in a table like this, but what about if I say what's f of 50? Do you really want to have to go clear down to 49 to find 50? I'd guess not, probably. So we'll talk about how we can convert those, but that is a recursive formula because you have to rely on the previous term. Write that in your notes. So write a rule for this sequence. Well, this is kind of a cool sequence because we don't add anything there. We add 1 there. We add 1 there. Oh man, this is not going to work out nice. What else do we see? Well, I can see how I get 8. 3 plus 5 is 8. 2 plus 3 is 5. 1 plus 2 is 3. Ooh, but how do I get these two? We're going to have to rely kind of on a recursive type of a formula. So for F1 and F2, we would just say, hey, these two, they don't need each other to get the next one. They're just equal to 1. But for anything beyond the first 2 terms, n the term number 3 and beyond, we can use this formula. We just take the previous two terms and add them together. So it would be f of n minus 1 being the previous term plus f of n minus 2 being the one previous to that. And that's how we get the entire sequence. I hope you recognize that sequence. If not, type it into Google and see what it gives you. It should give you a cool history and stuff. Come to class and share that. Okay, see you in class.